Now, in this question, we are going to explore the idea of using clustering as a form of feature engineering. So the first thing that we need to do is create a variable that we're going to try and predict. As when we're doing our feature engineering, this will now be for supervised learning. So we are going to create a binary target variable y, which is just going to denote whether or not the quality is greater than 7. So greater than 7 will be equal to 1, 7 or less will be equal to 0. We're then going to create a variable called x with k-means. And that's going to be from our original data. So it's going to be a pandas data frame. And we're going to take that data and everything that we've worked through so far. If you recall, we added on a glom as a column as well as k-means as a column. So we'll drop quality, color, and a glom, which will leave that k-means. So we have all of our float columns plus that k-means column. And then we're going to create another pandas data frame, which is x without k-means. And that's just taking what we just created from x with k-means and dropping k-means column. And then for both data sets, we will use stratified shuffle split with 10 different splits. We will fit 10 different random forest classifiers. And with that, compute that ROC AUC score of these 10 classifiers, find the average of each, and see which perform better, the one with k-means or the one without k-means. So in order to do so, we're going to have to first import our random forest classifier. We will also import our ROC AUC score, as well as our stratified shuffle split. So hopefully you recall all of that from the course when we did supervised learning. We're then going to create our target variable, which is just when the quality is greater than 7, we set that equal to 1. So if we say just this part, data quality greater than 7, that will return either true or false. Setting it as type int converts that true to 1 and the false to 0. We then initiate our objects x with k-means, which is just going to be our data set that we currently have worked towards, but dropping a glom, color, and quality. So we still have k-means in our float columns. And then x without k-means, we'll take that x with k-means that we just defined and drop the k-means column. So now we have these two different pandas data frame. One is just the float columns, which is x without k-means, and one is the float columns with that k-means column as well, which is x with k-means. We're then going to initiate our stratified shuffle split object. And then we're going to define this function, which will allow us to pass in an estimator. And that estimator, a spoiler alert here, will be random forest classifier, but we'll see how we'll use this again for logistic regression as well. And then an x and a y. So our different features and then our outcome variable. So first we initiate an empty list of ROC AUC. And that's because if you recall, we're going to create 10 different values and then take the mean of each of those values. So we'll append each of those values to this empty list. We take train index and test index, 4 values in our SSS.split for our x and y, depending on the x and y that we passed in here within our function. And because this SSS is defined to have 10 different splits, when we run this for loop, we are running through 10 different iterations of different stratified shuffle splits. So different splits of our data that have ensured that there's a stratification that's a certain amount of data quality greater than 7 shows up in each one of our different train and test sets. So then we set x train and x test using those train indices and test indices, and we set y train and y test with those train indices and test indices. We can then call that estimator that we defined up here that we're passing into our function and call .fit on our training set that we defined. And then we can come up with our actual prediction, which is going to be estimator.predict on our test set, on our holdout set. And we can do the same for our predicted probabilities. If you recall, if we want that ROC AUC score, then we need the predicted probabilities to actually create that. So we get the probabilities. That's going to output the probabilities for both of the classes. We only want the positive class, so we're taking all rows but only the first column, not the 0th column. And that's going to be our different scores. And then we can call for each one of our different iterations the ROC AUC score for our actual values, that's the y-test, as well as the scored values that we just computed. And we will continuously append that to our empty list so that we get all 10 different ROC values. We then take the mean of that list and we will have the average for the different ROC scores across those 10 different splits. So now that we have that function defined that will output that average across the 10 lists, we could set our estimator here to random forest classifier. So we have estimator equal to this object. We pass that in to our function that we just defined, along with x with k-means. So this is with the column of k-means, and that's going to be our x, as well as our target column y. And then we're going to do the same thing, running that function to get the same estimator except on x without k-means. So with our data set without that extra column. We run this, and we can see that without k-means cluster actually did worse than with k-means cluster. So we performed better when we had our k-means cluster as input into our random forest. Now, what I'd like to do is explore the idea of changing the number of labels that we will incorporate when we create this new feature, or this now new set of features if we think about this in regards to one-hot encoding. So we're going to say for n equals 1 through 20, we fit a k-means algorithm with n clusters. So first 2 clusters, 3 clusters, so on. And we then have to one-hot encode it because otherwise 19, label number 19, will be thought of as greater than label number 5 or label number 10. So instead we want those each one-hot encoded so that there's no ordinal value to each one of those different values. And once we have our one-hot encoded version of that column, we're then going to fit a logistic regression model and compute that average ROC AUC score. And then we're going to plot that average ROC AUC score for each one of our different numbers of clusters. So I'm going to run this while I explain it because it may take a little bit of time. But the way that we start off is that we're going to set x basis equal to just those float columns. We're then going to initiate our stratified shuffle split with only 10 splits, as we did before. We're then going to define this new function, create k-means columns. So as I mentioned, we can't just create that one column with multiple labels. We have to one-hot encode those labels. So we say km equals k-means with a number of clusters equal to whatever n we pass in. We're then going to fit on just our float columns. And then when we call km.predict on our x basis here, we're actually outputting each one of these different labels. So if the number of n was equal to 20, we'd have values 1, 2, 3, 4, all the way through 19, actually starting from 0 up until 19 to have our 20 different clusters. We then take that column that we just created, and we call pd.getDummies on that column. And now we create, if there was 19 different columns, and having a 1 or a 0 if that column happened to be a 1, a 2, a 3, so on and so forth. We then concatenate just those float columns to those new k-means columns that we defined. So that may be up to 20 columns that we're adding on. And then once we have this data frame, the idea is that we will be able to pass that in as our data frame and then fit our models. So we initiate our estimator as logistic regression. We say the n's, the number of clusters that we want to run through, are 1 through 20. We're then going to get our list of ROC and AUC values by calling that getAverageROC10 splits that we defined just above in the cell above. We pass into that the estimator. Our x value is going to be this create k-means outputs. So remember, this output will actually output a pandas data frame that's going to concatenate onto that original data float columns our new labels, one hot encoded. And then using that same target variable for each n in our different n's that we have defined up here. We're then going to plot that out. We initialize our plot, and then we just plot the n's versus the different ROC AUCs that are output given the model, given the function that we're running here. So we've already ran this. Let's look down at the results. And we see it jumps around quite a bit as we add on and reduce some of those clusters. So that closes out, and this is just after over 10 iterations. That closes out our section here on the different clustering methods, gives you an introduction to how you can also use these different clustering methods to actually do some feature engineering. And with that, we close out our section on clustering, and in lecture we will move on to dimensionality reduction. All right, I'll see you there.